And we're live. Okay. A.
Hey.
Well, not hey, A.
Hey.
That's like the Canadian version. Okay.
Hey.
So, when we left off, we already went through all the stuff on 1.5, right?
Yes.
We had time in class to work on 1.5. I have your stuff over here. I still have not gotten to it because mother of the world. Okay. So, literally, the sky rained crap down upon me. So, we went through same thing. Okay. We should have time in class today. Wait,
I don't know if I did.
I think I had like a piece of paper from you.
Yeah. Okay. I have my pen.
Okay. Um, so we had 1.5 was last Wednesday into Friday. Friday, we finished off like example, just a little bit of review. Hey, remember this stuff? And then we had time to work. Not only did we have time to work, we had time to go through it. So we've already checked it. Does everyone remember? That's bright. Oh, there we go. Okay, does everyone remember the, hey, come on now. That stuff. Like, do you remember how to plot coordinates? If I have a coordinate, I can list my x and y. Do you remember, here's my domain, here's my range? Do you remember how to make the mapping between them? Remember, cross the wires, right? Very, very sus. Okay? To make your mapping between here's my domain and here's my range. So we ended off with that, and then we had about a half hour, 20 minutes left at the end, and I said, instead of me doing another thing, if you're already done with everything, cool, you're done. Chill, relax, you earned it. If you're not, you got some time to get junk done. You should have in your packet every single thing except for progress check 2, every single blank filled in, done. And you have had a week to do that. So, don't worry about anything until, so we just did 1.5. Oh, yeah, Hannah's with us now.
Fine, thanks.
On our team. Cool stuff. Okay, so we're going to be starting there today. So you just pick up where we hit the ground running. Which I need to stop saying because Mythbusters actually proved hit the ground running does nothing. Like they would be trying to run in midair and they kind of like chuck people out of a bus or like onto a treadmill or something, and it never made them faster. So the phrase literally means nothing. So yeah. We already went through all this. You had time to work on all of it. What we have not done is a daily quiz. Oh, good thing that we spent 2 days on it. Get them. Here's a set of 4 coordinates. I would like you to turn those 4 coordinates into both, not a mapping, a table. And, I don't want that. I want a mapping. Insert, shape, thing. Shape fill. There. Ha! I win. I want you to take those 4 coordinates and turn them into a mapping. Jeez, get aggressive, why don't you? And I also want you to graph them, just to show that you can still graph them. Remember there was a nice little cheater that we wrote for our coordinates that we should probably have next to this if graphing hurts our brain? Okay, go ahead and use that. It's open notes, open resource, open all the stuff except your noisemaker. Keep that one closed. I want to know what you know, not your neighbor. Okay, so if you have like a folder or a notebook, usually it's like a folder and a notebook. Folder so you can have this and any other handouts we have. Notebook because at the beginning of every class, every time we finish a lesson, we're going to do a daily quiz on it. Okay, exactly what Kai's doing over here. Another reason I put you next to him is you would just, you'd say 0.5 relations. Forgive my third grade handwriting, it's upside down. And we would just do the thing. We score them ourselves. I tell you how to score them up. And then every time we do a quiz, like an actual test, you just turn this stuff in and I check it. That's it. Now, you don't have to do this one unless you just want to run through it for giggles because you're in Algebra 1 or half?
I was in Algebra
1. So it's probably been a while since you've seen relations and functions.
Yeah, basically.
Okay, so give you the short version. You know Spaceballs?
No.
No? Oh. It's a
My
good
mom
movie.
does. I
Good
watched
movie.
a little bit of it with her.
Okay. So the idea is out of every coordinate, x's and y's, we also call them domain and range. That's right here. Okay, they got special names. This is the input, this is the output. So when I say domain and range as a mapping like this, I would just list all my x's as domain, list all my y's as range, and then I would connect the dots, kind of like playing Among Us. You know, you just grab the...
Little wires.
Yep. Okay, connect your wires. So we showed if you have a table, well, all your x's is your domain, so your domain is just all these numbers. Your range is all the y's. But since we said 5 twice, we don't actually have to say 5 twice.
Okay.
It would just be that two numbers both go to 5.
Okay.
So we did them as tables, we did them as mappings like this, and we did them as graphs. If you just came out of McCreary's, then you're probably familiar with just at least getting the coordinates on there. I always tell kids to make this little cheater next to it just so they remember which way is which.
Okay.
So like this. Since I went left 5, negative 5, because x, negative 5. I went up 4, so up 4.
Okay.
So this little cheater, also everything in my room is open notes, open everything. So I want you to write stuff like this all the time, okay? Same thing here, and this is kind of what we're doing, is you would list out domain is all of your x's. You can write them in order, you don't have to, so like negative 4, 5, 6, 9. And then all of your y's. And you'd say negative 8, negative 1, and 0, and then you would connect the dots, right? So you'd say 6 goes to 0.
How do we know 6 goes?
Because they're together in the same coordinate. It is literally a mapping. It's saying if I press the 6 button, it'll give me a 0. And we're going to talk about that analogy a lot today, like it's like a controller mapping or a pot machine. If I press the negative 4 button, it's going to spit out a negative 8. If I press the 5 button, it's going to spit out a negative 1. If I press the 9 button, it's going to spit out a 0. And that's why I didn't write it twice. I can just draw 2 arrows going to it.
Okay.
Do you always draw it as an increasing value from lowest to highest?
I don't force it, but I model it to say we should be doing it because it's going to help us later on when the numbers get gross. So that's really what it was, is just domain and range, listing them, connecting the dots, and having those. So, yo. Well, that's good that it is, because that means that the last lesson went okay for us. Okay, I'm hearing way too much noise making. Right. We should definitely not be blabbing if we don't have anything written on our paper besides the problem. Okay, y'all did really good with this stuff last week. I just need you to finish it. Yes, sir?
All you had to do was graph it, right?
And make a mapping.
Okay.
Remember, go back to the section we were just in. Mappings, these.
Okay.
Okay? If you don't remember what a mapping is, go back to your notes where it says mapping, like we were doing there. Yes, sir? Okay, now this is the graph. The mapping is this. Remember? Draw a mapping.
Technically,
That's your table. Now, if it's a one-to-one relation, your table and your mapping are going to look almost identical. But not all of them are one-to-one, and we're going to talk about that today and what makes them special. What?
minus 11, 11.
Yeah.
Yeah. I also have like 3 other cards that say target creature gets +2/+2 in menace, but cannot attack you.
Yep. The different vowels. I actually have a deck where my entire point, it's like Mean Girls, meangirls.deck. The entire point of it is to take everyone else at the table and force them to hit each other so that they owe me favors. So, yep. It's good stuff. Okay. Do we have our graph and our mapping? Or are we still...
I'm just confused on the mapping. Getting the graph, kinda.
Well, if we're fuzzy on a mapping, maybe we go and look at what a mapping is.
Oh, okay.
It's good stuff. Who do what? That'll suffice. Now we'll just make sure you did it right. We're just plain going to put that away, Amos Geneva. Is anyone still rolling? Or have you gotten as far as you're going to get? Okay, still going? Kev, finishing up?
Yeah.
All right, dude. Called him Kevlar.
Great.
I remember the diagram and stuff.
And that's
it's
where
kind of confusing.
these, remember those?
Yeah, I have
Okay.
this.
So use that to plot your points. Left or right, up or down. Left or right, up or down.
Except both y and x are -2.
Well,
You put the negative sign there, so you know.
if the x says negative, then go that way too. And if the y says negative, then go that way too. So,
Oh,
okay.
So start here, go to.
Follow your map. Yep. Okay. I'll give you a minute to finish up if you're still going, but we got to get rolling here. because I really, really, really want to get 1/6 done today. I think if we did okay with 1/5, 1/6 should be a single day adventure.
Is it like almost the same?
Is this finger the same as those fingers?
Yes.
You're still
Shorter.
They're all fingers.
No,
Actually, they're pointed.
All thumbs are fingers, but not all fingers are thumbs kind of thing? That's today. Okay? We're going to talk about some of those relations are special. Some of them follow a special rule, and that lets us do fun stuff with them later in math.
You are killing my brain with what you just said.
Mr. Sullivan.
All thumbs are fingers, but not all fingers.
That is so tough.
No.
Why can't we tip thumb?
No, you can, you just have to have really, really good dexterity and strength.
How are you gonna work that minus that -2 in there?
You can do a handstand.
Your feet are naturally evolved to support your entire weight. That's why your calves are so thick compared to your wrist and your forearm. I can tip toe like this because my calves have developed to be almost 5 times as strong as my forearms. If I had the balance and coordination to onto my hands, I could tip them. Hello! First, the mapping. A mapping consists of domain and range. You can put them in these cute little boxes if you want. That's not even a box, that's like a blob. But whatever. And in your box and or blob, we're going to plug, what is domain? X's, inputs. Now, I write mine in numerical order. You don't have to do that. I put mine -2, 1, 3, because I prefer to have them in numerical order. You do not have to. I'm going to put range as all of my outputs, my y's, and I see a -2, 0, 1, 4. Then I will connect the wires and say 3 goes to -2. So draw your line. 1 goes to 0. Draw your line. -2 goes to 4. Draw your line. 3 goes to 1 as well. So mine is really mixed up. It's almost like a cat's cradle, right? Y'all remember doing that with the little string thing?
Yes, I do.
Okay. It's pretty messed up like that because I put mine in numerical order. Is there anyone who didn't? Just wrote them as is. Did it end up a little neater than this? Okay.
I kind of did mine like random.
Well, that's okay.
I just looked at a number.
As long as it maps, right? As long as triangle reloads like it's supposed to, you're good.
So if you get domain and range on the wrong side,
If you who what?
if you get domain and range mixed up.
Okay, now if we swap them entirely, but are they still going to the right number?
Yes. I think.
Okay, we'll address that when we get to our points. It's not as bad as you think, you just flip-flopped, okay? Next up, if I'm going to graphify, remember, we can do x, y. X's are left to right, minus plus. Y's are down to up, minus plus. And tells me where things go. My x's, +3 means right 3. -2 in the y spot means down 2. Over 3, down 2. 1, 0 means right 1, no up or down at all. So just there. -2, 4 says go left 2, up 4. Left 2, up 4. And 3, 1 says right 3, up 1. Right 3, up 1. So let's get to those points. First of all, did you... I'm going to say 2 for each and 1 for the getting the order correct. Okay? So, like, let's say Shane paired everything, paired the coordinates where they're supposed to be. You just swapped your domain range here. Okay, 1 off. Now, if we swapped everything here and swapped everything here, okay, we swapped our X's and Y's. I consistently did this one thing wrong. I'm going to make a note to myself to fix that. I would consider that 1 off. But if we're talking about, well, I swapped domain and range here, but then I also, like, put a 2 and a 3 on 2 separate dots to represent 3, -2. Okay, then we don't even know how to graph. Then we're talking about 1 off for missing the domain range, 1 off for swapping numbers here, 1 off again for I didn't even put them on the same spot. So, is there anyone who needs me to come take a peek at their paper and say, what is this? I don't even know. Okay.
This right.
3.
I don't think I did.
Negatory.
What?
Meaning we wrote our coordinates in separate spots instead of a single location.
Yeah.
We don't have the mapping at all.
The mapping, that's what I thought that, like.
Okay, you at least listed stuff. Okay, you at least listed stuff and attempted this. I'm gonna call it a 2. Okay? Yep. Anyone else? Yeah? Wait until we got some downtime. What's up?
Rethink.
Okay, so
So I thought
3, 2.
X and Y were supposed to go. I thought X was going to go up.
Okay, so you just transposed X and Y on both of them, but all of your stuff, like instead of 3, 1, you went to 1, 3. So you're still doing the right directionality. You just swapped what means what. I would still call this whole honkin' thing a 4 out of 5. Okay.
4 out of 5.
Yeah, we can fix this by putting that blue thing over there. We're gonna just tattoo that like on the back of your hand. Okay. So then whenever you, I'll just draw it with really, really stinky marker.
No, thank you.
And then every time that you're thinking, do I need to do this? You go, yep. Okay. It's not as big a deal as you think it is, bud. It's just, I need to remember which one comes first. Because what they do, you still did correctly. Just which one goes where, that's a different thing. Okay, anyone else? Cool. Then, make this go away, save. And we went through all of that, so we don't have any work stuff to go through. Instead, we're going to head straight into 1-6. All right. So I want you to draw. Back in the day, the way that my teachers said, 20 some years ago, was
Looks like something on a doctor's seat.
This looks like a meat processor.
It is.
okay. It is the function machine.
Oh, I remember this from 6th grade.
Okay. The function machine is the rule. Okay. I have an input, I have an output, and I have the rule. Okay, what the function is supposed to do. Okay, now we've already been doing this with relations. The idea is, if I take the chicken and I chuck it into the machine, it spits out chicken nuggets. Okay, that is its purpose. Okay, that is its purpose. I would like for you to add into here, this is my domain. This is my range. And this is going to be the expression that tells me what I'm doing with the input. So, pretty simple. I would have the function of x is to x. I need to make that bigger. Okay, so the way that we write this is the function of x is, and then I give you the rule. And it's going to be some expression. The way I write it is that f in front, it's not a variable. It's not, it doesn't mathematically operate on anything. In fact, this is the name of the function. Okay? For example, the chicken nugget machine, I would call it the grinder. Okay? So I would say grinder of chickens is to grind up chicken pieces to give me chicken nuggets. Okay? So f is the name of the function. Yes, ma'am. Can we put a cow instead of a chicken? But we don't do beef nuggets. We do chicken nuggets. People. And then Damien's back here like, I'm just going to destroy the evidence. Throws Landon in. Okay? No, not people. Okay? All right. Back here. Come on. I know how this is set up, it looks really ugly. It looks really complicated. But this says f is the name of my function. X will be my inputs. The job of my function is to take 2 times every one of my inputs. So what happens if I throw a 4 into this machine? 2 times 4. There you go. We just got to get used to the notation. If it went da-da-da-da, then fix it. Just turn it off. Okay? Seriously, whoever's phone made noise, just fix it. Okay? If I throw a 41 into the machine, the purpose of the machine is to double it. So I get 82, right? That's what a function machine does. Here's my input, do rule to my input, spits out range. Okay? That's the purpose of a function. What makes a function different than a relation? Who in here has too many siblings? Ooh, okay. Given the weary expression on Geneva's face, I'm going to go with that. Okay? So if we have the sibling machine, and we pick up Geneva and we chuck her in, who comes out? Who comes out? No. We throw Geneva into the sibling machine. Who are the siblings? Okay. So that would be the outputs. Input, The rule is you are related. You have parental connection. Therefore, why?
What does that sound? What is that?
That's all in the family members.
Okay.
Is that like an electrical sound?
Now, on the other hand, if we had something specific, okay, how many siblings do you have?
More than one.
More than one. Okay. That would be a relation because there's a rule, right? Input this kid, output those kids.
Wait, so are you basically saying that she's made of all of her siblings?
No.
I mean,
Okay.
How I look at it.
Maybe you're still not getting this idea.
I don't get a single
Quiet.
thing.
How about this? Pop machine.
What? What?
A pop machine.
Oh, yeah.
Okay. If I go and press the Mountain Dew button, the purpose of the machine is to spit out a Mountain Dew. Right? What happens if it doesn't? Besides table flip. Okay. Would you say that that machine is functional?
No.
It's not doing what it's supposed to, right? This is the difference between a relation and a function. Whatever that noise is, make it stop.
I think it's one of the lights about to go out.
No.
I don't think it is. I think it's someone shooting.
Okay. Here's the difference between something that's just a relation versus something that's a function. Something that's a function, every single button does one thing, and only one thing. If I press the Mountain Dew button, it gives me a Mountain Dew. If I press Dr. Pepper button, it gives me a Dr. Pepper. If I press the Dr. Pepper button again, if it's a functional machine, what should it do? Give me another Dr. Pepper. Meaning, -6 goes to 0 and nothing else. I don't press -6 again and now it gives me an 8. It does what it's supposed to do. -1 does only one thing. 3 does only one thing. 5 does only one thing. But if I press the Mountain Dew button, it gives me a Mountain Dew. Cool. I press the Dr. Pepper button, it gives me a Dr. Pepper. Cool. I'm like, hey, I want another one of those. I press the Dr. Pepper button again, it spits out a cherry Coke. What the? Okay. This is no longer a functional machine. That's the difference between a relation and a function. Where I was trying to go with the sibling thing is that if I say sibling, for a good chunk of you, the sibling relation is not a function because you have more than one sibling. Because when we toss Geneva into the sibling machine, more than one output comes out. Because I just get the image of like loading her into a catapult and boom. Okay? It'd be fun. Like, be honest. If we could just load you into like a trebuchet or something and launch you into a giant ball pit,
That would be amazing.
wouldn't that be fun?
I'd recommend.
Okay. So, but if you were to take me and throw me into the sibling machine, nothing. No output. I'm an only child. Okay. Some families get big, and it also depends on how you define your family. I'm a huge proponent of found family and family of choice. I consider Aaron Bowerly. You all remember Mrs. Bowerly from middle school?
Yeah.
Her husband. I consider him my brother. Like, he's family. We have no blood relation whatsoever. That's my family. Okay? So maybe that's how I define it. But maybe in your family, maybe you have mom and dad and stepdad and stepmom. And maybe you define your family as these 11 siblings. Okay. It's how you define it. I'm saying when I get thrown into that machine, nothing's coming out. Like it gets clogged. Okay? Because I have no siblings. The difference between a function and a relation is whether one thing comes out of that button or multiple things come out of that button. Okay? Pretty simple. If I press the Mountain Dew button, it gives me a Mountain Dew. I press the Mountain Dew button again, what better it do?
Jacob, you ice.
Okay, that would not be functional, right?
Right.
That's not a function. How many times you been in your own car and you press the, you're going to honk the horn. Guy in front of you needs a little bit of a reminder as to his social status. Okay? If I honk the horn, I expect it to make noise. If I honk the horn again and my windshield wipers start moving,
Or your car starts going real fast.
that is not a functional machine, right? So when I press the -1 button and it gives me a 1, and then I press the -1 button again and it gives me a 3, it's not a functional machine because it's not doing what it's supposed to. Okay? You press volume up, it gets louder. You press volume up, it turns off. It's not a functional machine. Okay? Now, every one of these buttons that we're pressing, you notice they're all domain. What is another word for domain? Input, X's. So the way that I see that on a graph is my X's all line up in a vertical line, right? Like this right here. This point that they have marked, that's -3, 3, but this is -3, 2. This is -3, 1. -3, 0, -3, -1. Every single time it's a -3 thing, right? So if I press the -3 button and I only get one thing, if the vertical line only hits one thing, okay, the -3 button's doing the one thing. It's a function. And I keep going. And I press this button, and I press this button, and I press this button, and every single time it only hit one point. I pressed the -2 button, it did one thing. I pressed the -1 button, it did one thing. I pressed the 1 button, it does one thing. And then I come over here to this one, and I press the 3 button, it does two different things. Think about that. You're in the middle of playing a game, and you're like, okay, if I aim right over through this window, grenade. All right. Okay. Now if I aim through this window, and then it like drops it in front of you. It didn't do what you told it to, right? It is not a function. Look, it's raining you. Okay. I've had that happen in real life with a dodgeball. Okay. So it's really, really easy to determine if something is a function or not. You just look for, does every one of my domain go to only one of the X? Does every button go to one thing? Okay. Come over here to the example. First up, this is why I was willing to spend so much time on relations. Can you put those coordinates into the domain and range boxes? Just like we did in our daily quiz? Okay. List the X coordinates of the ordered pairs in the domain. So I'm going to say X, 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 and X. Be careful. What am I actually putting in there? Am I putting in -1, -2, 1, -1? Why not? I only need one of the -1s. So I'm going to say, now I'm going to say -2, -1, 1. Again, I like it in order. That's me. Doesn't have to be you. Then I'm going to list my Y coordinates. All go to the range box. So here's a Y, here's a Y, here's a Y, here's a Y. I'm going to put them in order because that's how I like it. 3, 4, 5, 9. Now, draw your arrows. I say -2 went to 9. I say -1 goes to 5. 1 goes to 4. And -1 goes to 3. Then I got to ask myself the question. Every time I pressed one of those domain buttons, did it just do one thing? I press -2. It only goes to 9. Cool. I press -1. It goes to 3. But it also went to 5. The -1 button did two different things. In fact, I can do this. I would highlight that to say, this is my troublemaker. I hit the brake and I slowed down. I hit the brake and my trunk popped open. It is not a functional machine. Okay? So down here, I'm going to say the domain value -1 was paired with two range values. It went to 3 and 4. So I will say it is not a function. That's it, guys.
Wow.
Like, I mean, we're going to do more with it, but are we okay so far?
Yeah.
You make the mapping like we did in 1.5, but now we're looking for the special stuff. It's not enough to just be a relation. It's got to be a special relation. Kind of like the difference between y'all in high school. If you're going to have a relationship, maybe make sure that it's a monogamous one so no one gets bent out of shape. Y'all not mature enough yet. Can't handle that polygamy, so. Anyone who claims they're poly in high school usually is just likes to get around. We'll tell you when you're older. So, try it again, except now it's going to be with a graph. Vertical line tests. Everyone have a pencil or an ID or your driver's license, your Qdoba gift card, something. Okay?
I'll use my fake ID. Yeah, you want to see it?
All right. So, everyone's got their vertical line, whether, like other classes might call this the pencil test, I've heard kids call it. The pencil test, the vertical line test. I get a vertical line, and I'm going to run that vertical line across the paper. See how it only hits once at -4? Riley. At the -4 button, it only hits once. It's good. Keep going. At the -2 button, it only hits once. We're still good. You keep doing that all the way across the paper. At 1, only hits it once. And then we come over here and hit 4.
Hits it twice.
Two different outcomes. Okay. So, I don't know. Gavin's got a Fruit Ninja at home. Okay, you seen like the bullets, right? Or like the baby bullet or the Fruit Ninja or whatever they call it, where you throw everything in and make smoothie. They're like special. They're special ones, right? Okay. Gavin's like, yep, I'm gonna make myself a fruity. Here we go. And he presses the button and it goes, and he's like, okay, cool. He presses that same button again, and it shoots off of the stand. Is that a functional machine? He pressed the 4 button and got a 1. He pressed the 4 button and got a -3. It's not a functional machine. Okay? So, you're going to draw the vertical line through all the points. Now, this is what the book actually wants us to do. They want you to draw the line through each of these, making sure you can actually hit the dots. Will any line pass through more than one point? Yes. A vertical line passes through, now I'll list those coordinates. For 1, remember it's always x then y, and through 4, -3. So this relation is not a function. Pressed it once, frappe. Pressed it twice. I hear stories from people who work at McDonald's. Like, man.
I don't like those. There's been some fun that. You like to get on not this shiny. I'm sorry. That one was pretty funny.
Okay. That's it. It's the relation. You got to stop me. As soon as I pick this up, you got to lead the target, dude. I'm not going to hear you for the next 3 seconds. Okay. Here, I'll come down here and put in 4, 1 and 4, -3. Yeah. No, especially after the last couple of weeks, y'all, between school and home and just like torn in a million directions, my brain ain't working. Now can I? Okay. All right. So what I'd like you to do to start with, I think you can make the mapping because we already did the mappings. We've done this before. Turn each of those into a mapping. Then I want you to argue with your neighbor and see, is it a function or not? Did every x go to only one y? Does every domain go to only one range? If I press the Mountain Dew button twice, does it give me a Mountain Dew twice? Or does it spit out some like caffeine-free diet cream soda?
Okay, cream soda is good. Anyone tells me
Them's fighting words. I will see you after school at skate park.
deal.
I'm putting it on YouTube. Okay? All right, please. You got coordinates. Put them in the table. Make your domain and range mapping.
I literally had cream soda at lunch. Thank you. I always have that at my house. When I'm at issues.
Never been my thing. But please do the mappings.
Can I get a drink?
Do the mappings.
You're gonna get a cream soda.
Do one mapping, then get a drink. Come back to the other one.
Okay. That's the deal.
Same thing I told Riley. Do mapping, get drink, come back doing a mapping. Thank you for asking this time. Yes, sir.
So could this one put like domain and range or like X and Y?
Okay. Each. I would be cool with you saying X or domain here, paired with one Y or range value. I would take either. Yeah. Because remember, the X's represent domains, so those are sort of synonymous. Riley, dude. Let's tone that down to about a 2.
The energy level right now is through the roof.
I noticed.
I have had a lot of caffeine. Usually makes me tired. but I don't know what's going on.
I don't even have to have caffeine.
I know.
Do the mapping.
I'm doing that. I'm doing it.
No, you're doing the flapping
How do I make it minus 1?
because you're doing the flapping.
Oh, I put it in minus
Pencil there too if you want to use it. So is number 1 a function?
Unfortunately, no. The class as a whole has lost that.
So since it's going to two different ones, it would not be
I
functional.
don't know. Remember, if I'm looking for whether it goes to 2 or not, I'm looking for this way. This is bad. This is okay. Because, is it possible to have 2 Mountain Dew buttons?
Yeah.
Right? This button is doing what it's supposed to. This button is doing what it's supposed to. They might be doing the same thing, though.
Okay. So I'm a little stuck. That part's easy, but then just what the relation would mean.
Okay, so do this.
Oh yeah, I gotta do that too.
Okay, uh-oh.
Oh shoot,
Why
yeah.
do we have more than one? Okay. So let's get rid of him and say 0 goes here.
-1 and 3.
Okay, do the rest.
Yeah. 2, 2.
Okay.
And
Okay.
each domain value is paired with
It's a real doll, just invisible.
Just chill, dude. Hey, try your mapping over here.
Right here. Because on the domain, -4 and 0, go to 5.
Can you have a pop machine with 2 Mountain Dew buttons on it?
Yeah.
So this button is doing what it's supposed to, and this button is doing what it's supposed to. They just both happen to do the same thing. So that's okay. If you have this, that's okay.
okay.
But if I have this, that's bad.
Okay. So,
Okay.
So
each
since
domain
every
Domain value is paired with what kind of value on the right side?
range.
one
Okay,
range.
go for it.
where do I put that?
Jackson,
In the
what'd
next
you get for
slide.
Jimmy John's? I got the number 5 sub, some salt and vinegar, some chips, and I got some water.
Okay. We got our mappings. Now what?
So the relation, that's the part I'm confused on. I don't know what that means.
Okay. You're supposed to tell me, is it a function or not? So does the 0 go to only one place?
Yeah. So
Does the -1 go to only one place?
Mhm.
Does the -2 go to only one place?
Yeah.
Does the -4 go to only one place?
Yeah.
So they're all doing exactly one thing, so it is a function.
Okay. That makes a lot more sense. Okay. And then that would just be X and Y then, right?
Okay. Because the domain value, so see, 2 is going to one place, 1 is going to one place, but look at what 6 is doing.
Well, so it's not.
So I'll say the domain value 6 is paired with 2 range values. It's going to...
1 and 5. Okay,
So I press the 6 button, it gives me a 1. I press the 6 button again, and for some reason it's spitting out a 5 now.
Yeah.
So it is not a function.
Okay.
Okay. So like, see how these both went to 5?
Yeah.
Can I have 2 different Mountain Dew buttons on the same machine?
Yeah.
As long as they're both giving me Mountain Dew, they're
Yeah.
good, right? But here, I'm pressing that Mountain Dew button,
That's
and
two
it's
different
spitting out
ranges.
a cream soda, and now Riley's getting all worked up, getting
Yeah.
all hot and bothered about cream soda. Okay?
Yeah.
So, okay, most of us seem to do pretty good, so I'm going to run through these a little faster than usual. Here we go. List all your x's. There's x, there's x, there's x, there's x. -4, -2, -1, and 0. I'm going to list all my y's. There's a y, there's a y, there's a y, there's a y. We got 0, 3, and 5. When I start drawing my arrows, 0 goes to 5, check. -1 goes to 3, check. -2 goes to 0, check. -4 goes to 5. Some of us got a little bit wigged out by this. They said, well, no, 5, it's got two things, so it's not a function. No, no, no. These are the buttons. This is the input. This is what it does. Is it possible for me to have two different of the same button on a pop machine?
Yes.
Is it possible to have two different buttons on your remote that both bring up Disney Plus?
Yeah.
Yeah. Maybe I have a Disney Plus button, but I also have a favorites button. Okay? I live in Disney hell. This is all we watch. Okay? So I have, right? All day long. And I hate musicals. Like, they make me want to rip my eyelids off. So, no. So, if I press the -4 button, it gives me a 5. Can I still press a 0 button and it also gives me a 5? As long as they're each doing what they're supposed to, each domain value is paired with one range value. So the relation is a function. The next one, on the other hand, I've got a 1, 2, and 6, a -1, 5, and 9. When I start drawing those, I say 6 goes to -1, 1 goes to 9, 6 goes to 5, and 2 goes to 5. Okay, now two things going to the 5, that doesn't matter. I can have more than one Mountain Dew button on the pop machine. But look at what that 6 is doing. I pressed the Mountain Dew button and it gave me a Cherry Coke. I pressed the Mountain Dew button and it gave me a Mountain Dew. I pressed the 6 button and it did two different things. It is not a function.
Oh.
Okay?
So, if it's on the right side and they're both going to.
So that was the key that we made on here, a couple of you, as I was walking around. If you ever see this, that's okay. I can have two x's going to one y. But if I have one x going to two different y's, that's like Grug hand paint red, smack, and they died. You can't do that. Okay? We've actually been watching The Croods a lot lately because our internet's been out since Tuesday, so we have to go through our DVDs. Okay? Words are hard, I know. Domain value 6 went to two different range values, both -1 and 5, so it is not a function. Okay? So, we can come down here to a step-by-step practice.
Did it. Let's go. That's how you do it. I did it.
Anyone else?
Okay? So in this case, we're skipping the mapping entirely. It's going straight to, here's a bunch of coordinates. Tell me if it's a function or not. So list all the x's. X's, 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 x's. -2, 10, 0. See how we had a 10 again? I'm actually just going to kind of put a little arrow above it so I remember that. And then an 11. Okay. The 10 happened twice, so I got to watch out for it. I pressed the Mountain Dew button more than one time. So I need to make sure that it's doing what it's supposed to both times. When I list the y's and say we got a 9, a 3, a 15, a 15, 3, 9, well, I suppose if I didn't do it in order for this one, I won't do it in that one. 9, 9 again, 3, and 15. It does say to draw a mapping. Should I do that? Just so I remember, this happened more than once? Okay, it says step 3, draw a mapping. I don't have to if I'm smart enough. Okay? Every x has to go to one y. Every domain has to go to one range. 10, that was the x that happened more than once. So just go back to the 10s and say, 10 goes to 9, did the 10 go to 9 again? I turned on my windshield wipers. My windshield wipers made the rain go bye-bye. The next day, I turned on my windshield wipers and my horn started going, nah. It is not a functional machine. I pressed 10, it gave me a 9. I pressed 10 again, expecting it would do the same thing, and it gave me a 15. Okay. Now, if I was going to draw the mapping, it's not that hard. We're going to list out all of our x's that were on this line, -2, 0, 10, 11. I'm going to list out all the y's that were on this line. Shut your hole, Riley. Connect the dots. Draw your arrows. Say -2 goes to 9. 10 goes to 9. That's okay. 0 goes to 3. Cool. 10 goes to 15. Ah, crud. And 11 goes to 15. So it almost looks like a Jacob's ladder. Y'all seen those?
Yeah.
Jacob, I got one at home. Or do I have it in here? No? Okay. A Jacob's ladder is, it's like a stack of wood blocks and they got like little fabric loops on them. So if you tilt it, it goes thunk, 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 thunk. Okay? Toys for people who are 80. Okay? They haven't been cool in a long time. But that I ain't 80. I said toys that are cool for people who are 80. I didn't think it was cool when I got one, but I have one. So, I got it from people who happened to be 80 when they gave it to me. So, do you see how the 10 goes to two different spots? I press the 10 button, it does this. I press the 10 button again, and it didn't do this. So it is not a function. Not a functional machine. Okay? So down here, does the mapping show a function? No. Explain your answer. What is it that makes it not functional? 10 goes to 15 and 9. That's your answer. Write that. Say, not a function, 10 maps to 9 and 15. Okay?
Wait.
See, I completed the circle because now I can hold you hostage.
Just yell when you accidentally taps it.
Dun dun.
Scares them.
It's actually not a good idea to genuinely startle me. Now this is like 7, 8 years ago, but I might have accidentally choked out another teacher. There was a gal who was all about hugs. Like she wanted to give everyone hugs. She was a hugger, and she kept saying that she was going to give me a hug, and I kept saying, "Leave me alone." And she hid behind my door one day to catch me as I was leaving to go to the bathroom or something. And she jumps out, and like had my hand cocked back and ready before I realized what was going on. And she's the sweetest old lady too. You should just.
Old lady? What did she say?
I'm getting hugged.
And then what did she say? And after
So please don't surprise me.
what if I put like a RC snake in your room?
There might be profanity involved, and you won't be in possession of an RC snake anymore. Ugh smash. All right, determine if the relation is a function. Come on. Come back with me here. That was the blue stuff at the bottom. We already did that, bud. Okay, check this out. If I draw a vertical line at 2, it only hits it once. If I draw a vertical line at 3, it only hits it once. If I draw a vertical line at 7, it only hits it once. It's good, right? Every time it only hit once. So I would say it is a function because it passes, we call it passes, the vertical line test. Every one of my vertical lines only hit a point, so it passed the vertical line test. Can I do the same thing with number 5? I heard yes and no. On number 5, can I draw a vertical line and it only hits one dot every time? No. Right here, well, it's on your paper too. If I say it is not a function because it fails the vertical line test. Okay, fails the vertical line test. If I were to press the -2 button, it's going to give me a 3 and it's going to give me a -1. Two different things. I'm typing a bunch of stuff in my calculator, I hit enter, it gives me answer. I type a bunch of stuff in my calculator, I hit enter, it turns off. It's not a functional machine. Okay? Okay, these ones are trickier. I want you to look at every one of the x's. -8 goes to 6. Go look at the rest of them. Do I ever say -8 again? As an x?
No. Well, what if you have it there, but you don't use it?
I'm asking, does -8 ever occur again?
Yes.
This one goes to 6. Does this one? No. But I don't need to do the mapping. If I'm only looking at the coordinates, I don't have to do the mapping now. Because I press the -8 button. Cool, it does a thing. When I press the -8 button again, does it do the same thing?
No.
No. So the relation is not a function. Because -8 maps to 6 and 0. It mapped to two different things. Okay, what about the next one? Does every one of my x's go to just one y? They can go to the same y, I don't care. But does every x go to only one y? 4 goes to 22. Do I use 4 for an x again?
No.
No, so we're good. I only use the button once. 0 goes to 1. Do I use 0 as an x again? As an x again? No. 15 goes to 1. Do I use 15 as an x again?
No.
No. 3 goes to -8. Do I use 3 as an x again? Since I never pressed any of the buttons more than once, I have to assume that it is a function. And my reasoning is going to be every x maps to one y. Every button does one thing. Every x does one y. Every domain does one thing in the range. Every button performs one task. That would be extremely confusing if the hazard lights turned on my hazard lights, but they also popped my hood. Every button should do one thing to be a functional machine. Kids these days. All right. Words. Everyone look at the creepy blue babies. Children's Development Center.
Children's Development Center? Isn't that like that one little place in the hospital? You put a baby in an incubator?
I don't think that is.
Megamind!
It's Papa Smurf.
You went to this place called School.
All right. If
What is that? What is that supposed to balloon. Huh?
Dead Smurf.
Oh! Hey! You need a white one.
Okay. So, creepy blue children. They opened business for 3 years ago. All right, dial it back in. Come on now. In the first year, got 65 kids. 82 kids the second and third years. X is the year of operation. Y, the range, is going to be how many kids are there. So if I wrote that as a table, remember, every time they have this problem-solving practice here, you get one almost identical to it in your assignment. So it says in the first year we had 65 kids. What do I write for the next 2 blocks? In the second year, how many kids did we have? And in the third year, also 82. But you notice which one of you is actually doing what you're supposed to.
I'm doing what I'm supposed to. I have everything down that you've done today.
Okay.
Tell me that you're working.
You ain't working.
I am, though.
Okay. So my domain is 1, 2, and 3. My range is 65 and 82. Where does 1 go?
65.
Where does 2 go?
82.
Where does 3 go? Is it a function?
Yes.
No.
Yes.
Argue!
Yes.
Don't just yell louder. Use a reason.
It's like the Disney princess thing.
Okay, quiet. Elaborate.
Like, it doesn't have to
the one button that says like Disney Plus, like on like a Roku remote, and you click like YouTube or something, and then it goes right there. But you could go to favorites or something. So
You can have two different buttons that go to the same place, right?
same place, and then two different.
Okay, this is why I say things in different ways. For some reason, the remote thing worked for Riley.
I can't explain it.
Okay?
I know what you mean.
Can we use big kid words? Okay, I never repeated any of the elements of my domain, right? I never said one more than once. I never said two more than once. I never said three more than once. I'm going to say, is it a function? Yes, because every x maps to exactly one y. Every x maps to one y. The 1 goes to one place. The 2 goes to one place. The 3 goes to one place. Can they go to the same place? Yeah. I can have more than one Mountain Dew button on the machine. Aspartame actually gives me a huge headache.
Wait, every X goes.
Coca-Cola, 0 sugar, 0 calorie cola.
What goes through the school's head to put this in there?
Federal nutrition mandates.
Okay, but like, why?
But I feel like if kids want to
This is so for diet soda.
I get your
It's the same thing. It's so sugar.
Ah.
Deletes the whole thing.
Take a look at that.
You're still fat.
9 and beyond. So here's the deal. Because we had to re-wrangle multiple times in here, because we had to keep coming back, dialing it back in on a lesson that should have been done 20 minutes ago. Get working. Okay? It's not that hard. You have what, 10 problems? 12? I'd say 10 or 12 problems until Tuesday afternoon is probably reasonable. Okay? So,
This is right. It's your right hand. This is not right. Does that help?
that works. No, I like that one. I like that one.